Okay, so let's start with 67 through 72 from 321. This is assignment 6. So I'm going to go to the ebook. Hopefully you have your ebooks opened. Hopefully you read them a little bit. And we are learning how to solve inequalities with 1 or 2 variables. Okay, you've done inequalities with lines, but what if we have like 2 parabolas and we want to know greater than or less than this? Okay, so that's what so having different colors is helpful too. So if you have colored pencils or highlighters or something like that where you can make pretty graphs, that will be helpful. So if we look at number 67 here, it's kind of going to go off the sections that we learned earlier in 312, I believe. So in the previous section, you learned how to use the graph of a system to solve an equation. How can the graphs y equals 2x squared plus 5x minus 3 and y equal x squared plus 4x plus 3 shown at the right help you solve an inequality? Consider this as you complete the parts below. How can you use the graph to determine the solutions of this parabola equal to that parabola? What are the solutions? Okay, so how can we use the graph to solve these? So let's write these equations down first for 67a. Let me get my writing tool here. And I'm going to write it somewhere up here. 3-67a. We have 2x squared plus 5x minus 3 equals x squared plus 4x plus 3. How can we use the graph to find this solution?
I thought it was is lesser than or equal to x squared.
There's no less than or equal to right here.
Wait, I'm looking at the 367 thing that I just printed out.
Right, that's for later on for CD. That's
so
for later
on. Does that mean I do this in my notebook instead of on that piece of paper?
Yes, that's exactly what that means. All right, so anything I write down, you should be writing down. So since we're right here, we're finding this equal. So if we wanted to use a graph, we'd have to put y equals this and y equals that in Desmos, right? So that's what we're going to do. We're going to split it up. It's one equation right here, but this is one parabola and this is another parabola. To get the 2 parabolas to graph, we put y equals the left side, y equals the right side to get 2 separate graphs. So I'm going to click on the Desmos. They've done it right here. So we're going to, if we click on the E tool right here, okay, it's graphed it for you. They've put the 2 equations in for you that I just said to use. Y equals 2x squared plus 5x minus 3 and y equals x squared plus 4x plus 3. And how do you know which one is which? Well, this one's the purple one and this one's the orange one, but what if you weren't using Desmos, because you're not allowed to use Desmos on a test or a quiz or anything like that? I could tell that the purple one's skinnier, right? Like it's narrower. So that tells me it's the one with the coefficient of 2, right? Because the 2 is going to make it narrower. Okay, a lot of late people today. I'm not sure why you guys are late and interrupting the lesson, but you guys need to get here on time, please, or I will make a waiting room and leave you out of the room. This is very disruptive when I have chimes throughout my lesson. All right, so yeah, the orange one's going to be the wider one, which is going to be y equals x squared plus 4x plus 3. Okay, so how do we find the solutions of this? How do we use the graph to find the solution of these 2 things?
Look at the intersection points.
Find where they intersect, right? So I'm going to erase some of these things that I made right here. Yeah, so we're going to find the intersection points. So we just click on it right here. Where the two intersect are at -3, 0 and 2, 15. So let's write that down on our paper, on our notebook. X equals -3 and x equals 2, right? Those are our two solutions for part A that you're writing in your notebook. Okay, if I go back to the book to see what else we have to, so that was what our solutions are. That's how we use the graph to get the solutions. For part B, obtain the resource page or use the e-tool that we were just using. Label each graph with its equation and highlight each function with a different color. So one was purple, one was orange. How did you decide which graph matches the function? Well, this one had a coefficient of 2, which would make it more narrow. Okay. We could also do X-intercepts. It's pretty easy to find the X-intercept by factoring the this equation right here, x plus 1 times x plus 3. And you get -1 and -3. You get -1 and -3 for your X-intercept. So that's another way to tell that that's the orange graph. Okay. On the resource page, label each graph with its equation and highlight each function with a different color. So on your resource page, right, you should have this page printed out. Make one orange or purple, whatever colors you have. This on Desmos, this was purple, and then on Desmos, this was orange. So whatever colors you have, you can highlight on your resource page. If you don't have a resource page, you'll have to draw this. Okay, and you can go back and draw it later if you need to. I'm going to proceed with the lesson. This is all on Google Classroom, so you can pull this up at any time. All right. Let's see, next part. How did you decide which one? Click on the lower right corner of the graph to view it in full screen. So it's just you coloring which was which, and you should identify it also. You should put like this one is y equals 2x squared, and then the orange one you need to write like this one is x squared plus 4x plus 3. So put that on your paper, please. And then it says use the graph to identify the x values for which 2x squared plus 5x minus 3 is less than or equal to x squared plus 4x plus 3. How did you locate these solutions? How many solutions are there? How can you describe all of the solutions? Okay, so get my pen back up. So if I want to say that this part is greater than this part, okay, we can do this on the Desmos part actually. So let me pull the Desmos screen back up and I can erase all this. Let me just clear all this drawing stuff. Okay, if I pull the Desmos part back up, oops, that is not what I wanted to do. Let me go to that. Okay, okay, so on your Desmos screen, they typed it in for you, which is nice. Okay, so they typed in this part. So I meant to write this down on our paper. So go ahead and write this part for part C on your paper. 2x squared plus 5x minus 3 is less than or equal to x squared plus 4x plus 3. So go ahead and write that down. What is this going to look like? Let's click on the graph thing and look what got shaded. So this is what we need to shade on our paper. And they also had, let's see, let me click on this. If I click on this, now let me take that back real quick. If I click on this, look what happens. The lines come through right here. So there's a solution from -3 to +2. And if you remember, that's what our solution was. Our solution was -3 and +2. And then when we click on less than or equal to each other, it's all the area in between that. Okay, so the way that we write that is, get my pen, you're writing this on your notebook. Writing pad back. X is greater than or equal to, what is this, -3 right here? -3 and less than or equal to 2. Okay, so X is greater than or equal to -3 and less than or equal to 2. So that's all this area, you guys, right? And notice that it wasn't just like, it's not just this area. We're going to do that later on today. Like, it wasn't just in between the parabolas, because a lot of people want to do that. They want to go like this and they just want to do in between. It's not always going to be in between. You know, it could be this area out here. It could be this area over here. It could be this area over here. It could be this area over here. So there's several different answers. There's like 5 different answers that we could have when we do inequalities, right? This one just happens to be less than or equal to. So it's going to be this whole region right here. And why is it not just this region right here? And why is it the whole thing? Our answer, what you should be shading in, is this whole thing. Okay? So hold on a second. I have to check a chat message. Okay, thank you. All right, so yeah, don't just shade that in. It's the whole thing that's shaded. Okay, so use the graph to identify the x values for which this is a solution. So we use this graph to say, hey, the solution is all these numbers between -3. So the solution is any point in this shaded area. So this is a solution right here, which is what? -215, right? That's a solution. This point right here, which is what? -2.8. This is a solution. This is a solution way down here, which is, oh, these are going by 2's. Sorry, that's -1. And this is -2. That's correct. This is a solution right here, which is 1, -5. Okay, so any point in this shaded area is a solution. And of course, it continues up and it continues down forever. So as long as the x is between -3 and 2, right? If the x is -3 and 2, it doesn't matter what the y value is, x. As long as the x is between -3 and 2, it's a solution. Y could be anything. Y can go up to infinity. Okay? So that answers our part for part C there. Okay, I need to clear this away and go back to the book. So got to clear this writing. And let's go to part D here. How can these solutions be represented on a number line? Locate the number line labeled 2x plus value is less than that on your resource page. Use a colored marker to highlight the solutions to the inequality on the number line. So there's a number line on the bottom of your resource page. Let me see down here, right? And so we need to mark the answers on there. So we're going to go for x is greater than or equal to -3 and less than or equal to 2. How do we mark that on this number line? So we're going to have a circle here at 3, and we're going to shade all the way down to 2 till we get to 2. So that means our solutions on the number line are any number where x is between -3 and +2, right? Between -3 and +2 are our solutions. X can be any number between those. If it's past -3, if it's -4, -5, -6, it's not a solution. If it's 3, 4, 5, 6, it's not a solution. Okay, so that's on your resource page. I have to clear this away again. Go back to the book page. E, what about the inequality 2x squared plus 5x plus 3 is greater than? So what if we flip this, right, and make this less than, and we flip it to greater than? What are the solutions to this inequality? Represent your solutions algebraically and on a number line. Okay, so we're going to go back to our Desmos because this is in Desmos right here. So let's go to Desmos and scroll down. So now they have, so I'm going to erase this one, turn this off. And now I'm going to switch it to greater than, and let's click on it to see what it graphs. Oh, look what it graphs. Greater than is going to be the numbers greater than these values. So it'll be all these numbers and all these numbers, right? So how do we say that? We say x is, let me get my writing tool here, and you're going to write this on the bottom of your resource page, or, well, you're going to write this in your notebook, and then you'll graph it. So it's going to say x is this way, which is, so we have to do them separately. We can't do them together. So x is less than -3, or, and I ran out of room here, x is less than -3, or, because when they go in opposite directions like this, that's going to be an or graph, which means it's a greater than graph, okay? We're not going to use one inequality. Or x is greater than 2. Okay, so that's for this section, and then we have 1 for that section. So that is how we write it algebraically.
Look what you know about. This what you
How
know
we write
about
it algebraically.
You
Just could mute your
fire ass bread.
things.
Desi, your
Unless
mic's
you have a question.
unmuted.
Yeah, thanks. Let's see. So that is the answer to part E here. I need to, let's see, get rid of this and go back to part E. It says, what about that? What are the solutions to the inequality? So back on your paper, the way that we would write that on here, the way we would show that, pen back, is go to -3, do an open circle and shade to the left, and at 2, do an open circle and shade to the right, right? So this one was closed circle, shaded in, this one was closed circle. So that's the difference between, this is greater than. So, and this is when we use the or. So or is more. That's a good thing to remember. Or is more. When you have more solutions, right, they're going away from each other. So this has way more solutions than this does. This has like a good amount of solutions, but this has more because this is going to go to infinity, and this is going to go to negative infinity and positive infinity. So this one has way more solutions than this one does. When do you use or? When are they going to go in opposite directions? When it's greater than. Greater than. Or is more. Okay, you're going to have or. So we had x is greater than -3, or we have this, x is greater than -3, or x is greater than 2. That's only going to happen when you have greater than. When you have less than, you're going to have a compound inequality. You're going to have x is greater than -3 and equal to -2. That's for less than problems. Okay, we use the conjunction and when we read this, and this is an or problem. Disjunction, disunion, they go in opposite directions. Okay, so part E. Gotta clear all this away and go back to, that was part E. Ready for 68 here. 68, consider the inequality 4 times the absolute value x plus 1 minus 2 is greater than 6. How many boundary points are there? What are they? Should they be marked with filled or unfilled circles? Mark the boundary points on a number line. Okay, so let's write down the problem. Let's write down for 3-68. 4 times the absolute value of x plus 1 minus 2. I forgot to put absolute value. That's a 1. Minus 2 is greater than 6. Let me write it over here because I'm going to need room to work. 4 times absolute value, x plus 1 minus 2 is greater than 6. All right. How many boundary points are they? What are they? Should they be marked with filled or unfilled circles? Mark the boundary points on the line. Okay, to find the boundary points, we need to like solve this, right? So how do we solve this? What should we do first to undo this problem? Let's add 2 first, right, to undo the problem. So we're going to get 4 times the absolute value of x plus 1 is greater than 8. Then now let's undo the 4 here by dividing by 4. Divided by 4, divided by 4. So we got absolute value of x plus 1 is greater than 2. Okay. Now, when we think about this, absolute value is greater than 2. Remember, this is a greater than problem, so they're going to go in opposite directions. Well, what numbers have an absolute value bigger than 2? That would be between -2 and 2. So it would be like all the numbers to the right of 2 and all the numbers to the left of -2, because those are numbers that have a distance bigger than 2, right? Because remember, absolute value means the distance that it is from 0. And the numbers that are more than 2 away from 0 are past -2 and past +2. Okay, but that's not our solution. That's just like, okay, that's helping me understand what this means. So how do I solve this absolute value? What do we have to do here? we have to split it into two absolute values, into two equations. The first equation is x plus 1 is greater than 2, just like it is, just drop the absolute values. Or, we're using or because it's a greater than symbol, or x plus 1 is less than negative 2. Okay, what did I do to get the second one? I flipped the inequality sign. I made the greater than a less than, and I made this number, the 2, a negative 2. You always do that whenever you have a greater than with an absolute value, okay? Because you have to have two solutions, right? Because absolute values have two solutions. When you have the absolute value of x equals 2, the answer is x equals 2 and negative 2, because you can have the absolute value of negative 2 equal 2. So how do you have two solutions? You put the same inequality, you just flip the inequality. Some people call this, I used to call this flip and switch. It's the flip and switch method. Okay, we flip the inequality and we switch the positive to negative. Now we just solve both of these. So to solve both of these, I'm just going to minus 1 from both sides. Get x is greater than 1. So that's or, down minus 1 from both sides here, x is less than negative 3. So that's my compound inequality. How do you graph this? If I graph this on a number line, it goes from negative 3, negative 2, negative 1, 0, 1, 2. From negative 3, I'm going to put an open circle, because there's no line underneath, and shade to the left. And then at 1, we're going to put an open circle and shade to the right. And look, the shading is going away from each other. It should go away from each other if you have a greater than symbol. The shading should go away. So all our solutions are 3, 4, 5, 6, dot, dot, dot to negative infinity, right? Sorry, that's negative 3, negative 4, negative 5, negative 6 to negative infinity. And 1, 2, 3, dot, dot, dot to positive infinity. So all those numbers between 3 and infinity and 1 and infinity, negative 3 and negative infinity and 1 and negative positive infinity are a solution. The only part that aren't solutions are this little section in between here and here. Okay, so that is how you solve that absolute value. Which portions of the line contain the solutions for this inequality? Which portions of the number line? How many regions do you need to test? Represent the solutions algebraically and on a number line. So algebraically, this is the answer. On a number line is this. It says we need to test this. Okay, so let's say I test 0, right? I'm going to test x equals 0. Should that work? Is that in my feasible region? Test x equals, it shouldn't work, right? Let's try it. 4 times the absolute value of 0 plus 1 minus 2 is going to be greater than 6, and this should not work. So you always do the absolute value part first. 0 plus 1 is 1, so the absolute value is 1, and then we times it by 4 here. 4 times 1 is 4, minus 2 is greater than 6. So 2 is greater than 6. That is false. 2 is not greater than 6, and that's good because we tested this point that is not in the region. So that tells me that this part should not work. Now, if I would have tested 2, if I would have tested x equals 2, it would work. If I would have tested x equals negative 4, it would work, okay? And I would plug it in here and it would work, okay? But I'm going to go on because we need to go on to like 3 more problems. All right, so that's the answer for part B. Need to erase all this beautiful work here. Makes me sad. I'm going to scroll down to problem 69 here. Bert and Ernie. You recognize those names, I think, from Sesame Street. Bert and Ernie are solving the inequality 2x squared plus 5x minus 3 is less than x squared plus 4x plus 3. They're looking at the graph in problem 67, and Bert has an idea. Can't we change this into one parabola and solve one inequality that way, he asks. Ernie asks, what do you mean? Can't we determine the solutions by looking at the graph of f of x equals x squared plus x minus 6? Bert replies, where does Bert get this equation from from those two equations. How does he get this from that? Think back to our previous sections. How do you get this from this? What can we do here? So let's write the problem down. This is problem 69, so please write 69. 2x squared plus 5x minus 3 is less than x squared plus 4x plus 3. Can we subtract everything? Can we subtract x squared over here and bring it over here? Can someone unmute themselves and say, yes, we can do that?
Yes, we could do that.
Oh, thank you, Mateo. I was just wondering if you guys are still awake. Minus 4x over here, minus 4x over here, right? Bring that 4x over here. And then I'm going to minus 3 over here, minus 3 over here. Okay, so that's going to make the right-hand side 0. And then we combine all this stuff. Well, 2x squared minus x squared, that's going to be x squared. 5x minus 4x, that's going to be 1x. And then negative 3 minus 3, that's going to be minus 6 is less than or equal to 0. So, that is how Bert got that equation. He combined the two equations, right? By like subtracting one from the other. Okay. Bert subtracted one side to the other. Side. Okay, so instead of having two parabolas, we can just have one parabola now. Make a sketch of this parabola and show how it can be used to solve the original equality. Okay, if I make a sketch of this parabola, let's find x-intercepts. So if I have x squared plus x minus 6 is equal to y, not 0, right? Well, if it's equal to 0, if I make it 0, I could just factor this and solve it to find our x-intercepts, right? It's a parabola, so this is how you find the x-intercepts. So I factor x squared, that gives me x times x. I factor 6 with a difference of 1, that would be 2 times 3. I need a negative 6, so this would be negative 3, positive 2. Set these both equal to 0 and solve them, so x equals negative 2, x equals 3. Okay, if we were to graph that, negative 2 would be right here. That would be an x-intercept. And positive 3 would be right there. That would be another x-intercept. And our, this parabola is going up. I don't know where the vertex is, but we could find it if we needed to, but I don't really need to right now. That's like the graph of the parabola. Okay. So make a sketch of the parabola and show how it can be used to solve the original inequality. Now, how do we do less than the other one? So our solutions, less than is generally going to be lower than the graph, right? So possibly it's that area right there, the area less than the graph. And I might need to make this graph dotted. So I'm going to make it dotted because it's just a less than. I don't want to include the points on the graph. Yes, somebody was asking a question?
Yeah, I have a question. Like, for our graphs, how rough should they be? Like, is it okay if we don't mark like some of the y-axis?
For this situation, yeah, I'm not making, I'm not labeling it because I just really want to know where the x-intercepts are right now. So yeah, for this situation, that's fine. All right, part C. Just a minute, mumbles Ernie. I think I have another method. Instead of graphing the parabola, can't we just rewrite the new inequality as x squared plus x minus 6 is less than 0, and then solve the equation x squared plus blah, blah, blah is equal to 0? This would give us the boundary points, and then we could test numbers in the original inequality to see the regions that contain the solutions. And remember, our solutions, I don't know, maybe they should be in between here. So let's draw a dotted line here and a dotted line here. Because shouldn't our solutions be like x is what? Greater than negative 2 and less than 3, right? Algebraically, that's how we should write. Like, technically, our x should be from here to here, right? That area right there. So this would give us the boundary points, and then we could test numbers in the original inequality to see the regions that contain the solutions. Use Ernie's method to solve the inequality. Does it give the same solution? Okay, so let's test numbers like over here. Let's test, so here's -2. What if we test, I don't know, -4? We could test to see if this region should be a solution or not. So I should test -4. I should test a number in here, maybe 0. And then I should test a number over here, like this is 3, right? So I don't know, I could test 5. So we could test those 3 numbers, -4, 0, and 5. -4 and 5 should not work. So where's the inequality that we have? Let me test x equals -4 and see what happens. When we test x equals -4, we get 2 times -4 squared, which would be 16, plus 5 times -4, which would be -20, minus 3 is less than -4 squared, which is 16, plus 4 times -4, which would be minus 16, plus 3. Okay, let's try this out. 2 times 16 is 32, minus 2 minus 3 is going to be minus 23, is less than, and this is 0, which is 3, 0 plus 3. 32 minus 23 is 9. So is 9 less than 3? No.
No.
No, that's wrong, right? So that's good because we tested a number that was not in the region. We tested x equals -4, and that means, that's not going to work. When I plug in 0, should it work? You trust me that it works? Can we skip that part?
Yes.
Okay, thank you. If I plug in 5, is that going to work, guys?
No.
No, it's not going to work. So you trust me, it's not going to work. We could plug it in, but I need to move on to other stuff, okay? So when I plug in x into the 0 into this, this is going to work. When I plug in 5 into this, it's not going to work, okay? Use any method to solve the inequality, blah, 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 blah. For part D, I'm just going to solve this really quickly. X squared minus 3x minus 10 is greater than. Let's factor this, guys. How do you factor 10?
Five and 2.
Yeah, 2 times 5, right? 2 times 5. And the x squared is going to be x times x. I want a -3. So it's going to be -5, positive 2. I set these equal to 0. I get x equals -2, x equals positive 5. But I want to make an inequality. Since it's greater than or equal to, I have to use or to separate my two inequalities. So x is going to be, think about it, it's going to be, here's -2, it's going to be a closed circle going that way, and then 5 is over here, it's going to be a closed circle going that way. So we want x to be less than or equal to -2, less than or equal to -2, or x can be greater than or equal to 5. Okay, so I knew these were my boundary points. Boundary points are like, where do you put the open or closed circle? That's your boundary points. You solve it, right? Just factoring 2 steps. And then since it's a greater than, I know they have to go away from each other. So x is less than -2 going that way, and x is greater than 5 going that way, greater than or equal to 5, less than or equal to -2. Okay, that one's done. Number 70. Told you this lesson's a bear, guys. It's not easy. All right, gotta scroll up. Scroll up, okay, or scroll down. There we go. All right, 70. Next, Bert and Ernie work on solving the inequality 4 times the absolute value of x plus 1 minus 2 is greater than 6 from the last problem. This time, Ernie has an idea. Why don't we solve this by graphing a system of equations as we did in 67? What system of equations would he graph? Make a complete graph of the system and explain. I like how we did it before, how we just did it algebraically. So I'm going to skip that one. I want to go on to the other. This is kind of pointless. So actually, let's skip 70. annotate. Just do it the way we did it last time. I don't see a good reason to do that. So we have two more that we need to do. 67 and 69, you looked at these inequalities. Okay, but we didn't have y's in them. Okay, we just had these two parts combined together, but there were no y's. Therefore, our solution was just like x is, I don't know, greater than -3 and less than 2, something like that. But what happens when we put a y in it? Okay, now we have to have a y as part of a solution. So, which points make both inequalities true? For example, does the point -3, 0 make both inequalities true? Does -1, 1 and 1, 5 make both inequalities true? So we have to test these, right? In both of them, not just one of them. They have to work in both. So let me clear this. And okay, so this is 71, 3-71A. So our inequality is y is greater than or equal to 2x squared plus 5x minus 3, and y is less than x squared plus 4x plus 3. Okay, we are going to test -3, 0 to see if it's a solution. So we're going to plug in -3, 0 into both of these, not just one of them. They have to work in both. This is my x, this is my y. My y is 0, so 0 is greater than or equal to 2 times -3 squared plus 5 times -3 minus 3. Well, 2 times -3 is 9. 9 times 2 is 18. And 5 times -3 is -15 minus 3. This is good practicing how to plug in numbers into quadratics. That's very important. A lot of people have difficulty with this step. You need to practice this, okay, to be good and go on to pre-calc and calculus. 18 minus 3 is 3. 3 minus 3 is 0. So 0 is greater than or equal to 0. Is this true?
Yes.
Yes.
Yeah.
So this works. -3, 0 is a solution. -3, 0 is a solution. It should be in the shaded region, is what that means, right? If I were to graph this, it would be in the shaded region. Okay, let's try -1, 1 and 1, 5. I don't know. I think I know why they do 3. So we're going to test -1, 1. So x is -1, y is 1. Okay, so y is going to be 1. 1 is greater than or equal to 2 times -1 squared. 2 times -1 squared plus 5 times -1 minus 3. This is the part you guys need to practice doing. 1 is greater than or equal to, this is going to be 1 times 2, which is 2, minus 5, minus 3. This is operations that you need to practice. 1 is greater than or equal to 2 minus 5 is -3, minus 3. 1 is greater than or equal to -6. Is 1 greater than -6? Yes, so this is also solution. So this is in the shaded region. So it means if this is in a different region than that, they should both be, those regions should both be shaded. Okay, the last one we're going to test is 1, 5, right? 1, 5. This is my x, this is my y. So I'm going to go, oh, you know what? Doggone it, I just forgot. I just saw this right here. I only did it in one, huh? I need to go back and do it in both of them. So maybe I'll skip this one later. Let me go back and plug in -3, 0 into here, into this one right here, because I forgot to do this one. I just did this one. Big dummy me. Okay, so let's put in 0 here. 0 is less than -3 squared plus 4 times -3 plus 3. This is going to give me 9 minus 12 plus 3 is greater than 0. 9 minus 12 is -3 plus 3. That is not greater than 0, right? So not true. So it does not work. So even though -3, 0 worked in the first one, right, it didn't work in the second one. So this is not a solution. So this is actually not a solution. Okay, now I need to test -1, 1 into the second one because I forgot to put it in the second one. So I'm going to do that somewhere over here. My y is 1. is less than 1 squared plus 4 plus 3. That's a minus 4 because it's a negative 1, so that's minus 4. 1 squared minus 4 plus, that's right, okay. So 1 is less than 1 minus 4 is negative 3 plus 3. So 1 is less than 0. Is 1 less than 0?
No.
No, thank you. 1 is not less than 0. So it means this is not a solution. Negative 1, 1 is not a solution. So I would go ahead and do the last one, but I'm sure you're getting tired and so am I. So if I test 1, 5, I'm thinking it's gonna work because all the other ones didn't, but you know, you get the idea. You could test it and see for yourself. Do we have to graph these? Because I think that we have to graph them to see where the solution is. I graphed this. I have to erase this to show you guys the graph. Sorry, you need to take a picture really quick before I erase it. I'll get take a quick drink while you're copying that if you need to. Okay, done with my drink. I need to clear these drawings. I took the liberty of putting this in Desmos, putting both of these in Desmos earlier, and this is what it looks like. Voila. So I typed them in here, and one was greater than, so let me turn off so the greater than one is greater than or equal to is a solid boundary, and notice that it's like greater than is inside. It's above the parabola, I would say, because if you graph down here, this would be below the parabola. This would be less than over here, and this is greater than because it's going up. Now, if I click on the other one is this blue parabola right here, and this is less than, right? It's below, it's shading below. So where do the two shadings overlap, you guys? Right in this purple region, right? So this is what I need you to do. I think this is on your, if you have your resource page, this is on your resource page. You just need to shade in this area where they overlap. Okay, so just get your pen and shade in like that area right there. If you don't have the resource page, then just draw it. Just do a quick sketch. Okay, because so this was like greater than or equal to because it went like above, right? And then this was less than the other one because it went below, like down here. This is less than, right? Because it's going below. Greater than would be inside. It would be up. Up is considered inside the parabola, and then less than is considered outside the parabola because it's going down this way. Okay, so where they overlap is this region. So all the points that we tried -3, 0, right? We tried this point right here, which is a boundary point. How come that point didn't work? Well, it works for the red parabola, right? But it doesn't work for the blue parabola. And the other point we tried, what was the other point we tried, guys? Was it 1, 0? I don't have that screen. So what was -1, 1? I forgot. It was like 1, -1. It was 1, -1, I think. 1, -1. If that was the point that we tried, or actually I think it was -1, 1, wasn't it? -1, 1, which is this point. See, this is in the red area, but it's not in the blue area. So that's why it worked for one of them, but it didn't work for the other one. And the other one was 1, 5. 1, 5 is right here. That one is going to work, right? Because it's in both areas. So if we would have tested the last one, yeah, it would have worked for both equations. And it's really important that you guys test both equations. Okay? All right, so I'm going to clear this out. And again, this is on your resource page. You have to just shade the side in between the resource page, in between the two parabolas. All right, go back to, where's our lesson here? 72. Okay, now this part is pretty easy. For each of the following graphs, write an equation, inequality, or system that represents the solution shown. And this is like the last two problems on your worksheet for homework tonight. Note that the equations for the line and parabola are given. Explore the graph using, you can use the e-tool or Desmos, but we don't really need to. Okay, so for A, so you can't really print this out, right? I don't know if you can print it out. If not, just do a quick sketch, and you'll need to write down these equations. If I want to graph this, do I need a greater than or less than symbol in here at all? No. So this is the graph. So, you know, go ahead and graph this really quickly. Graph that, and then graph that. Where do they intersect? They intersect here and here. And then this is the equation. X plus 2y equals 4. That's that line right there, right? That's the line. And then the other equation is y equals negative 1/3 x plus 3 times x minus 4. That's the parabola because it's a quadratic, has 1x, 2x. So that's going to give me x squared when I multiply these out. So that's the parabola part. The x plus 3, that's my minus 3 right here, right? X equals negative 3. And this x plus 4 is my x equals 4 right there. So this is intercept form of the parabola. And we just leave it like that. Now, if I want to make this shading, I have the same exact two equations, but I want to make this shading. Is this greater than or less than? Am I going to change this to a greater than or equal to, or a less than or equal to? I want it to go down here. Is that less than or greater than, guys?
Less than.
That's less than. So we're going to write the same equation, but we're going to put a less than or equal to. Why do I put the equal to? Because is the line solid or dotted?
Solid.
Solid. So we got to put an equal to sign. Solid line. 1/3 x plus 3 times x minus 4. Okay, so that's one of the equations. Now I got to look at this line. Is this line dotted or solid, guys?
Dotted.
Dotted. And are we shading above the line or below the line?
Above.
Above. So that means it's going to be greater than. So I'm going to put x plus 2y is greater than 4. Okay, it's because it's above. The shading is above the line. It's not below the line. So it's going to be greater than. I didn't put an equal to sign because this is a dotted line. That means any number on the line is not a solution. Any of these numbers is not a solution. Okay, so here, now we're going to change the shading from here to these two regions. Okay, so in terms of this parabola, here's the parabola. Am I going less than the parabola or greater than the parabola? I would say that's less than, right? It's going down. It's going below the parabola. It's whoa, I take that back. I take that back. Less than would be inside the parabola, right? Isn't this shading outside the parabola? Right? So we undo that shading. So outside the parabola would be greater than. So greater than negative 1/3 x plus 3 times x minus 4. Hopefully you guys are still paying attention. This is kind of an important part of the lesson. I know this is going to be on the next test. All right, and then y is, for the line, is it below the line or above the line?
Below.
Below.
So that's definitely going to be less than, right? And it's a dotted line, so we do not put an equal to sign. Less than the x, oh, I'm sorry, it's x plus 2y is less than 4, right? And it's okay to put the less than here, even though we didn't put it in y-intercept form because this is a positive y. Okay, last one here. Let's see. In terms of, so where is the two shadings basically? Actually, there's 3 shadings. They made it a little tricky. They didn't put this little section right here. I don't know. Yeah. Okay, so let's say we're, in terms of the parabola, we want to shade inside the parabola, right? So what is that? Y is greater than or less than? It's basically shading down. That's less than or equal to, because it's a solid parabola, less than or equal to this stuff. Negative 1/3 x plus 3 times x minus 4. Okay. Now I want to change my color. Now I want to, in terms of the line, it looks like it's above the line, right? Because it's not below the line. It's not down here. So how do I say above the line for this? Greater than or less than? It's greater than. It's a dotted line, so it's just greater than 4. Okay, problem is we have actually one more constraint that we have to come up with. And we're almost done. You see this part here, guys? Look at this. There's a constraint right here. So I need to go to the right of this line, which is the y-axis. So how do I write all the numbers to the right of the y-axis? X is greater than or equal to 0. That is the equation of the y-axis, is x is greater than or equal to 0. So these are my 3 equations, inequalities, that I have to graph this region right here. Okay, and so you get to try this on number 15 and 16 on your homework, the last 2 problems, like, you know, what happens when you change the inequality signs? How do you get it to be this region? How do you get it to be this region? How do you get it to be this region? By flipping the inequality signs. All right, so I'm going to stop this recording here. If I can pull up my toolbar. Let's see. Oh, there it is. Pressing the wrong thing. Stop.